Dear students, now we are going to discuss some of the challenges in federated learning. Improving efficiency and effectiveness of algorithms is a major challenge in federated learning. There are many questions. How can I make my model faster? How can I reduce wall clock training time? Or I might do it, or it can be done by developing improved optimization algorithms. Faster and adaptive algorithms might resolve the problem, or shrinking the size of data model and reducing the training time from week to days or to hours maybe. Another important aspect is the scope of federated learning. Machine learning is supervised, unsupervised, and reinforcement learning and other areas of learning. We have to see how will we train the model, how will we control data loss. For these type of machine learning, for instance, unsupervised learning and semi-supervised learning, we can do it by observing the model that is being trained. But in federated learning, it is a bit unclear. The model that is running. Secondly, we can check the we can debug the model. The model that is running is not correct. What should we do? Possibly in traditional way, we have access to data set. We have data set and we see which rows in example of data set the model is training. So you can inspect the data to see what is happening. Is the model source of error? Is the data source of error, or coding of data or representation of data or something else might be model have some sort of bugs. Engineers can possibly detect and resolve it. But in federated learning, it is harder. You cannot grab data. When model is training, you cannot say the client to give me the examples, give me the data so that I may feed one by one and feed it one by one and see where there is error. So it's very important to keep in mind that something that is very simple in traditional machine learning is very complex in federated learning. Robustness to attack and failure is another challenge. How do we develop an algorithm or technique that are robust enough to prevent all the attacks and failures of devices? Devices can be hacked, they are wearable devices, data might be hacked and malicious data can be injected, and in result model will be trained on malicious data. It will maximize the loss although we have intended to minimize it. Another important aspect that is offering a challenge is ensuring fairness in selection of devices or selection of data model and addressing source biasness. This can happen because of sample biasness. We are taking sample and we are not taking care of bias, the amount of data, the distribution of data. These all are very challenging. We have to consider that sampling bias. We have to address the sampling biasness. Then when we are training our model, we have to control training biasness. Which model will be trained, which devices will participate in training round, how the models will be aggregated, which weight factor will be used to combine the model in generation of the combined model. These all need to be addressed. And then we have participating devices, device participation bias. Which device will participate in training round and which device will not participate in training round. We have to address all this biasness so that we may ensure fairness in our model training. In federated learning, privacy of users' data is more important. The most important thing is preserving the privacy of users' data. In federated learning, data is not moving along the network, data is not being taken from the data sources, data is remaining with the data source and at its origination place, whereas small size data model is being trained and is being transmitted to the network towards the server. So, as the data is not moving along the network, therefore data theft, there will be minimum possibility of data theft or data lost, because only small size model is moving along the network and privacy of users data is preserved using federated learning. Dear students, up to now we have learned about basic concepts of federated learning. Then we have discussed different types of federated learning, and we have applied federated averaging algorithm, and the working of federated averaging algorithm has been seen. And now we have learned about different challenges that are faced by federated learning. Now I hope that you have got all the basic concepts regarding federated learning. Even then, if you have some difficulty in understanding the concept, you may contact me through WhatsApp. Thank you.